Hello, hello. Can you hear my voice?
Yes,
Yes.
clearly.
Okay.
Okay, let's start.
Okay. Good morning, everyone. Uh, my name is Nurido Rizky. I'm from Department of Electrical and Computer Engineering, Faculty of Engineering, Syah Kuala University. Thank you for coming today. I'm going to talk about design of a LoRaWAN infrastructure for medium-sized smart city public transportation system. This is the outline of today's discussion. Straight into the background. Banda Aceh is the capital city of the Aceh province with a population of around 300,000 people. Like many other developing cities in Indonesia, public transportation in Banda Aceh is unreliable and of poor quality. The reason is because old and poorly maintained vehicles, irregular and unpredictable schedules, and undisciplined driver behavior like strikes and reckless drivings. To improve public transportation, the Banda Aceh government introduced the Trans Kutaraja bus system. The Trans Kutaraja bus has several advantages, including brand new vehicles, high service standard, straight departure and arrival schedules, lots of bus stop. However, another problem emerged. Many users complain that the bus arrival schedule remained irregular and users had to wait a long time at the bus stop. This problem because traffic congestions, boarding and lighting times, and driver skipping stop. Here are some potential solutions that I think could help resolve this problem. And First one, to detect arrival times of buses at previous stop, and then transmit arrival times data to central using LoRaWAN network, and use the machine learning model on server to estimate bus arrival times at the next stops, and provide accurate ATAS to passenger via apps or display at bus stops. And this is the LoRaWAN infrastructure design at the bus stop. Each bus stop will have a LoRa and device connected to the Raspberry Pi to detect or read the BLA beacons that has been installed on each bus. And the data read is beacon address, timestamp, and RSSI. RSSI is used to see the signal strength of the BLA beacons as distinctions between the left and right lanes of the routes when a bus passes, so that there are no reading error between the right and left lane bus stops if they are installed opposite each other. Via the LoRaWAN device, data is sent to the LoRaWAN gateway with a frequency of 1023 megahertz. In Indonesia, Indonesia law limits to use of the frequency at 9 uh, 23 megahertz. Data from the LoRaWAN gateway is directly forwarded to the server. Are using here using the open source LoRaWAN network server is cheaper stack and installed to AWS EC2. And via cheaper stack, data is passed to AWS Lambda and inserted into the database here using DynamoDB. Machine learning will also be run on AWS Lambda to predict bus arrival times. Then prediction result will be displayed via the application or display at the bus stop. These are the components we use conduct experiments. Here there is a BLA beacons, Raspberry Pi, Arduino with a LoRa shield, and for the LoRaWAN gateway, I'm used to is the Dragino DLOS 8 outdoor. And this is a cheaper stack look at the HTTP integration feature for passing data to DynamoDB via AWS Lambda. And this is a payload data example and to send to DynamoDB. Maybe that's my presentations. Thank you.
Okay, thank you very much for your presentation. Do you have any questions and comments for this presentation? Okay, so in your what in your research and development, you are trying to developing the systems.
Sorry, follow me is slow.
And you haven't implemented the old equipment and softwares, or you already start experiments?
Sorry, I cannot. Your voice is clear. Follow me is low.
Oh, okay. So you already start experiments using your systems?
Yes, I start this experiment in Augustus 2023.
Okay. So what kind of data can you share some data if possible, or you are now gathering the data, still gathering the data and it's not yet analyzed?
Uh, this is still a design or idea to help overcome the problem, the bus transportation in Banda Aceh, especially. Until now, we are still conducting experiment on ones. There are several problems that we encounter, including the gateway that we use still standard, so it is less sensitive. Especially since most of the urban areas in Banda Aceh are still green, or there are still many large trees in the middle of the city. When conducting the experiment, there were several bus stops that could not reach the LoRaWAN gateway. Maybe that's my answer.
Hello, I'm Adisar from AIT. Maybe I'm quite late today. I didn't attend for your whole slide, but I have some question about your architecture. So do you have any issue with the mobilities? Because you are the bus gonna use the LoRa, right? And then gonna send the signal to the gateway. So my question is like, how of your completeness of your coverage area is that gateway can cover all areas, and then when the bus is moving, so you can get the signal and then communicate to the gateway or not? Hello. My question is complicated. Are you there? Excuse me.
Okay, sorry. We installed the antenna of the LoRaWAN gateway not high enough, and the blocking it was a large tree. And this is problem for me. And maybe and a solution for this I offer discussion. Hello.
I could not catch your answer. I could not catch your word. What? Can you repeat again? I could
Sorry, can you repeat the questions? I'm also playing.
Okay, so my question is, do you have any issues about mobility? Because my question is, because if I understand correctly, you put one gateway in your scenario, right? Then the bus gonna
Oh, I'm not an issue. Uh, the LoRaWAN
why?
gateway, I deploy a maybe after this, just one for the LoRaWAN gateway.
I see, because your Aurora node is on the bus stations, right? Because it's not moving. The, and on the bus side, you use the BLE, right? And then just directly connect to the bus station. Is that correct? So there is no LoRa node inside the bus.
Uh, 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 is LoRa node is backups, right?
Yeah, I got the answer. Yeah.
Uh,
Yeah, thank you.
Install the bus stop.
Okay, thank you. And there is another question in the chat. And do you develop the LoRaWAN gateway? Hello. Okay, it's almost a time. So please answer using the chat box. Okay, thank you very much for your presentation. And I move to the next presenters. Next presenter. Next presenter is Mr. Sheikh Muhammad Salah QD. If you're ready to present, please start. Please share your slide and start presentations. Can you share your presentation? Okay.
Okay,
Okay, let's
you
start.
can hear me.
Yes. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Honorable mention for all participation. I'm Teguh Muhammad Salahuddin and Computer Engineering Department Electrical and Computer Engineering, Syahkuala University. Today I will present design Larawan infrastructure for an energy harvesting Internet of Things water meter system appropriate for medium-sized smart city. Background, Banda Aceh is city measure 61.36 square kilometer in Indonesia. As with other modern city, access to clean water is very important for the daily life of residents. Clean water in general managed by regional drinking water company, and every customer who use in service must pay a only bill determined based on the water usage. To end all water usage, there is a tool called an analog water meter that is installed in every customer house. Currently, the water measurement process is still carried out manual using analog measure instrument. Officers are required to visit customer homes every month to collect water meter data, but this method is not efficient and accurate, potentially cause discrepancies between actual water usage and record readings. The water meter is located inside the customer property behind a fence, making the default of officer to carry out manual check. As a result, there are times when data collect is measured in certain months. As a result of using analog water meter, customer cannot determine the amount of water they use. So user often feel there is difference between their amount used amount due to a lack transparency. Why current solutions are inadequate? The solution the current problem is to use a digital water meter that is connected to a pan internet network and require additional electrical power to operate, result in additional electrical and internet costs. So by implementing communication that support energy saving on digital water meter, this device can operate independently without relying on an external electrical power supply. The idea to overcome the problem of internet bill, we provide a solution in the form of using LoRaWAN, which analyzes radio wave and analyzes energy harvesting from water flow in pipes. The idea to design a LoRaWAN infrastructure for an IoT water meter system that is energy efficient and sustainable for smart city, where LoRaWAN only customer 50 milliwatt of power to transit data. This is the LoRaWAN communication star topology. On the left of image, there is a digital water meter installed in every house. we can call it N device. In this is a feature in device into three parts, namely N device, gateway, and server. This N device will send its reading periodically to central server. The data will be temporarily stored by the MQTT broker, which later customer can monitoring directly via MQTT. For the tool used on end device, we use LoRaWAN Shield RF 19.5, and for gateway we use Dell OS 8. For server we use Stack. This is open source, which can directly control the security and monitoring for end device and gateway by analyzing the 923 MHz frequency. Component used when testing distance. For the end device, we use a LoRaWAN Shield RF 95 with two antenna, where the cable antenna and built-in antenna are small. Our gateway use a Dell OS 8 and antenna from star frequency 923 MHz. Which is installed on top building at a height of around 40 meters from the ground. We use 923 MHz frequency to communication. We measure delivery delay and signal quality based on signal to noise ratio or SNR and receiver signal strength indicator RSI value. Data delay based on distance. From this data in can be conclusion as follow. The type of antenna has significant impact on the fast time. Cable antenna have better fast time than a small antenna. This is because cable antenna have a height against the small antenna. The distance between the measured location and gateway also has significant effect on the fast time. The further the distance, the longer it will take to establish connected. The improvement also influence the fast time, the presence of line tree and building around the measurement location can either LoRaWAN communication. This is because tree and building can block radio signal from the gateway. Test point location. The gateway is located on top Shakwala University Lab building, marked with a blue dot and height of 40 meters. The maximum distance is 1.56 kilometers with a measured delay time of 11 seconds. In area with many tall trees, the maximum distance is about 336 meters with the same data delay. Conclusion: Tarawa can cover approximately 0.61 square kilometer in distant environment. The choice of antenna is crucial. High quality antenna significant impact signal quality, as demonstrated by device with excellent cable antenna. In highly congregate area, signal quality is notably effect dividend at distance 336 meters with RSI of minus 93 dBm and SNR around minus 8.5 decibel. Thank you.
Thank you. Is there any question?
Thank you very much for your presentation today. I think this time you research area focused on the wireless transmission. But I think this application might be you have to consider about how often you get the data. So I mean just once a month or once a week or every time, every every minute. I think it's how say water usage analysis is very important by using this system. So, is there any idea you collecting the data? How often you get the data every household? Mute.
Sorry, I do not exactly to understand. Can
I mean, I think by using your system, proposal system, maybe what company will analyze the usage of water. So in this case, how often you get each household water usage data? It's quite important. And also, it's affect the traffic of virus transmission and server processing power. So, is there any idea you thinking about how often gets the data by using your system?
mm, just this is just a prototype. Okay. I cannot answer. Mm.
Okay, I think it's a quite important issue for this system.
Yes, thank you. And yeah, some comments coming in chat box. The analysis of water usage of household protein. This is related to the previous questions. And I have one question, and usually the water meter with meter is located underground, and how you evaluate the antenna, transmitter antenna, you install the underground, or the antenna height is very important to the radio communications. So how your experiments doing about the location of the antenna?
I don't really understand our question.
You in your experiments, you what transmitter LoRa1 transmitter is installed somewhere. You carry the transmitter and transmit the data, or you install the same location of the water meters.
And installed LoRaWAN in Universitas Syafala.
Yeah, yeah, yes. Yes, the LoRaWAN base station is located in the university, but how the transmitter site located in the underground?
Hi. I think the question is about like where did you install the your water meters? It should be in the household, right?
I installed it in on top of the building for the gateway. On
That is the gateway, right? But on the inside, the one that be far away from the gateway, 1.5 kilometers, you supposed to put them at the house. In my chat.
Okay, it's almost time, so the yeah, this question or comment continue to the chat box. Okay, thank you very much for your presentations, and we will move to the next presenters. So the next presenter is Mr. Nurufa Zero M. Scary. Okay. Okay, please start sharing your presentations and start.
Testing. Okay. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all of you. Okay, my name is Nurul Faizal. You can call me Jai. I'm from AUC Science Malaysia. Today I would like to present, actually it's not a research, it's more on works on my office. The blockchain enabled digital innovation, transitioning physical school to e-school. Okay, the idea actually is from Prof. Azman Samsudin from Computer Science School in USM. I'm the working guy lah. I'm the technical guy. Okay, he's already retired. The idea is he asked me to look for this open source tool to create a digital scroll which we issue it on the blockchain. So we then try to migrate all our physical scroll to the e-scroll. So all students will get e-scroll later. So every year, USM contribute around 6,000 graduates. So this year is 61 convocation. So it's 61 that times 6,000 roughly. Okay, then we have an issue on certificate fraud, where lately our cert has been so then legal office have problem to verify the scroll. They have to measure the distance, the font, and also they have to check all the record back on years back to confirm that this is graduate from USM. So that's the issue. So the problem is the current verification process for the USM scroll poses challenge for prospective employers. Additionally, the USM legal office face difficulties in ensuring the authenticity of the scroll. They use USM scroll to go to seek for the job, which actually is not ethics. So there's a need for an improved system or solution to streamline the verification process and support sustainability. So the objective is to assist the potential employer and employee in verifying USM scroll, then to help the USM legal office in confirming the legitimacy of the scroll, and also to reduce environmental impact and improve the overall user experience. So to study this, this is some guideline from NIST where either we want to move to blockchain or not. So based on this flow, do we need to share the consistent data? If no, then please consider email. If yes, does more than one entity need to contribute data? If yes, then data record once written are never updated, deleted. Then if no, then you need to consider database. Then if sensitive identifier will not be returned to the data store. No, then we need to use encrypted database. If yes, then we ask back, are the entities with the right access having a hard time deciding who should be in control of the data store? If no, then we use a managed database. If yes, do you want to tamper-proof lock all rights to the data source? If yes, then we can use a blockchain. This is kind of guideline to move to blockchain. So in order to achieve the mission, we are using BlockCert. So BlockCert is open source tool. Okay, it's a open standard for building apps and issue and verify blockchain-based records. It's portable, interoperable record that can be immediately shared and used anywhere in the world. So basically it is a JSON file. We contribute this JSON file, that certificate is just JSON file. Give issuer and recipient autonomy over how they use their record. So why use a BlockCert? Yes, it's open standard. No private data stored in the blockchain, only hash stored in the blockchain. Blockchain is stored, what is stored in the blockchain is one-way hash. So as I mentioned earlier, digital scroll in JSON format. So when the scroll is issued, its data is compressed into hash and locked on the blockchain. This will generate a receipt which will be used for verification. The verification service validates the signature of the issuer and the escrow data. It also ensures that the escrow status either expired or not, and the scroll are issued by batch. Okay, issued by batch. So this BlockCert we piggyback on the Bitcoin. Piggyback on the Bitcoin, not the public blockchain, with cost of 0.006 BTC, approximately is 25 USD. This is the yesterday rate, 25 USD. So per transaction, when we issue to the Bitcoin, this is the transaction fee we need to pay to Bitcoin. So why Bitcoin? Okay, why not other blockchain? First, why Bitcoin? Because Bitcoin is the most stable blockchain. There are around 15,000 nodes. This is the latest data I get from bitnodes.io. Okay. So how it works? Okay, how it works? We collect all the graduates who graduate on this year. We collect all the information, basically their name, what their course and major, and then we batch it and issue them with a cert tool to create a batch of certificates. So this batch certificate, then we issue it in the blockchain using cryptocurrency, of course, the Bitcoin. Then this cert will be signed. The hash of the hash of the certificate will be stored in the blockchain. So Bitcoin fee versus cost of scroll, transaction fee is about 0.006 BTC, approximately 25 USD. So average 6,000 students per convocation. So since scroll can be batched, the cost of a scroll is 0.042 USD, or in Malaysia is 20 cents per scroll. So how batch issuing works? This batch issuing works because because of this McEltree, it is possible to issue one certificate with one Bitcoin transaction. However, it's more efficient to use this one Bitcoin transaction to issue a batch of certificates. The issuer built a McEltree of certificate hashes and register the McElroot as the operator field in the Bitcoin transaction. There's a field. We pay from our keys, we pay to our public key. We send that to our public key. Then we insert the data on the transaction. When the transaction happened, we have been charged 0.006 BTC. And it's kind of like that. So, okay, this is the escrow format. The escrow format is in JSON format. Okay, this is for verification. Okay, as you can see here, this is for verification where there's a step of verification here. Okay, here there's a process where blockchain doing getting transaction ID, then compute the local hash compared to the remote hash, fetching the remote hash from the blockchain, and compare the hash, checking the market tree, checking the receipt, passing issuer key, and checking authenticity of the certificate. Then if all this okay, you check also is there any revocation, also any expiration date. If no, then the certificate is considered valid. This is demo for revocation. This happen sometimes there's case where our administration perhaps issue double records or any issue that student revoke because of any case. So we can place it, we can mark it as revoked because when it's stamped in the blockchain, that record cannot be deleted right in the blockchain, so cannot be tampered. So to achieve revocation, we have to mark in the system. So every time the user try to verify, there's an error there. The reason give double issue. This will happen if the certificate is being revoked. This is an example where the certificate is tampered. So when the verification happen, the hash is different between the hash stored listed in the blockchain. So there's an error there. The compute hash does not match the remote hash. So the certificate is invalid. So, okay. Back to the first example, there's a link of view transaction link. Okay, when we click there, it direct us to blockchain explorer, which is blockchain.com explorer, where we can verify this is the age of the certificates, how much cost for this. Okay, this one a screenshot. Okay, as you can see here, this is our public key. We send to our public key to create a transaction. Then there's a charge for fee. Okay, this 6,000 Satoshi. Then we can embed the data inside the transaction. So this is the flow to generate USM scroll. Basically, this is more integration with our database system in USM, where we trigger if any database run, we can because we want to automate it, so we don't need to ask any session to give a list of CSV. We just pump it through database. We collect it. Then we check it, either this is new scroll or we need to update or delete scroll. So if new scroll, then add info table. We target to issue the certificate once a month. So it's 12 months times by 25 USD is around 300 USD per year. That's the cost for the certificates. Okay, this block set has been used by University of Bahrain, MIT, and also the Malta launched this the record, this Republic of Malta. Okay, this is use case from the website where Canada this organization which already use this block set. So platform comparison, why this is my opinion, why use USM block set in public blockchain, because record is impossible to tamper, because it has 15,000 nodes, keep the records, because if you deploy a private blockchain, probably we can achieve 20 nodes, and yet we have to pay for the server, we have to pay for the internet things to keep the server live. However, we have to bear cost for 0.006 BTC for the transaction. Okay, that's all for me. Any question?
Thank you.
Please don't so hard.
Is there any questions in the comments? So in your system, the blockchain is used for the ensuring the resilience for these systems.
We use blockchain for verification.
Yeah. And why you choose the Bitcoin?
Why choose Bitcoin? Okay. Why choose Bitcoin? Okay. Okay. First of all, why we choose Bitcoin? Because we want the stability. We want the scroll is can verify in a long time, because this is official document. So if anything happen to the blockchain infra, then we have a problem, big problem, because they can verify back to the blockchain infra. So based on Bitcoin, based on the data Bitcoin, they have 15,000 nodes, which is very impossible to collapse. Very possible to collapse. So that's why we choose Bitcoin.
Okay. So other coins, there are many coins in the world. And
yes. Perhaps, yeah. Yes. Perhaps on the future works, we can go look for another alternative. We can have 2 or 3 blockchain infra to back the data inside the blockchain. So in case anything happen to this infra, we can refer back to this second infra, the second blockchain. Okay. Yes.
If it's just a testing or prototype phase, why did you choose the most expensive blockchain like Bitcoin?
Sorry?
I know that Bitcoin is the most stable blockchain in the world.
Okay.
But because this is just a prototype phase, it's just a research project. Why did you choose? Why did you start from the the most expensive blockchain?
Well, okay. Actually, for deployment, to develop this,
Mm.
actually, I can use in Bitcoin. They have a test node.
Yeah.
There's a test net and mainnet.
Mm.
Basically, for development, I use testnet to deploy, because that one we can take the Bitcoin from the faucet side, so we can develop it. Okay, but in the real development, in the production, when we use Bitcoin, as I mentioned earlier, the cost is just
Oh, okay. For now, you're just using the testnet.
for actually I have two more lah, mainnet and testnet. For development, I use testnet. Yes, correct. For development testnet. But on the demo side, it's using mainnet Bitcoin. It's a real blockchain. It's a official of it. It's a real blockchain mainnet. Okay. Okay.
Thank you.
Thank you very much for your question. Any more question? Yeah.
Yes, we have a still have a time. Do you have any standard comments?
Perhaps I don't know lah, we can collaborate. I don't know, in the research in this Apan platform. We can have a sort of a consortium of blockchain among, then we can use this block cert to pump the verification data on the infra side. I think that's good if we can have that.
There is one question from the chat box.
Can we migrate from Bitcoin?
Yeah.
Yes, it's possible. It's possible. But for now, my development focus on more on Bitcoin.
Okay. So you don't have any further comments and questions? I move to the next speakers. So thank you very much for your presentation.
Thank you very much. Thank you very much. Yeah.
So the next speaker is Mr. Franz Ahmad. You ready to start presentations? I think the speaker is not joining the Zoom. I think speaker is not joining the Hmm. Maybe the speaker, the schedule is start from the 10:05. Right, we will wait for 5 from the email. sent the email, but there was no response from him. This is the last speaker of this IoT working groups. He cannot join this presentation because this working group. We will wait another couple of minutes. The last speaker cannot join this the session, so we'll close this IoT working group. And, thank you very much for joining the IoT working group. And if you have any activities to be presenting in this working group, please provide the contents and make a presentation here for the next time. So thank you very much.